Hi, today I'm going to do a quick introductory session on how to create an animated shader using Vertex displacement in Unity ShaderGraph as part of the lightweight render pipeline. This is a lava shader which is based on an ocean shader created by Unity evangelist John O'Reilly, but much more simplified for the purpose of this introductory video. This video assumes a little bit of prior knowledge of the lightweight render pipeline, such as how to install it on your project. But apart from that, as long as you can just get into ShaderGraph, you've got all the knowledge you need. We'll just load up this graph now. Now, Vertex displacement functionality in ShaderGraph is a very recent addition, available since the beginning of October 2018. And what we're going to do today is create an animated height map within ShaderGraph, what I like to call a height map anyway, and apply the values to the vertex positions of the object. And we're also going to animate the albedo. So here is the graph, and as you can see, this is our PBR master, which is our output node, what everything is going into, and all the information from the shader goes straight into this node, and from this node gets applied directly to the object. We are using 3 main ports in this for our particular shader, although there's many more you can do, and this is just a very simple shader. You can do much more complex things in ShaderGraph. So if you look here, we can see this port, which is the position. This is going to be the position of the object, which the shader is applied to, so how we get our lovely wave going. The albedo, which is the color of the shader, and in this instance is just a base color of 2 lerping colors overlaid with these lovely animated ripples. And the emission, which we're going to pretty much disregard in this video because it's just a simple Fresnel effect in the multiplication node. I just popped that on there to get this lovely line of reflection around our shader, and it was in the ocean shader, and I thought I quite like how the look of that, so I'll keep it in there. But yeah, if we zoom out here, we can see that the graph is split into groups, just because as in any node-based software environment, it makes life a lot easier when you have just a little bit of organization. As we said before, this bottom bit is the Fresnel effect, which we're going to disregard. The middle 2 groups are the albedo, and the top is the position and vertex displacement. We're going to start with the position and then go down into how we create the albedo. This is the position node, which, as we have set to world, gets the position of the object in world space as opposed to local space, so we can access those x, y, and z values. Now through the split node, we're going to grab both the x and the z values and pop them into these multiplication nodes. The reason we use a multiplication node is that we can multiply that by these vector1 parameters, which are exposed to the editor. These vector1 parameters control the rotation of the waves, so we can choose which way we want the waves to face. So an exposed parameter, it's actually technically a property, which we expose it to the editor. So what we do is we right-click, type in vector, grab whichever vector you want, and then you can right-click that and convert to property. That'll appear in our parameter list, and that's just so we can expose it to the editor and customize it, and this is literally just a vector, which we can apply to something else. When we add those together, we get this lovely curve, which is going to be our wave. At this point, we are just creating what I like to call a height map. I think it is, but I haven't got 100% certainty on it. But from what I can see, this is a height map with black going to white, which each representing a value between 0 and 1, which we can then later apply to the vertices of our object. And then, yeah, so now we've got this little height map, we can multiply this by another vector1 parameter, which just allows the scale of the wave to be controlled in the editor. This is my favorite bit of the group, which I think is quite clever. So to animate the wave, we're going to take this time node, which accesses the built-in time function in Unity, multiply that by an exposed parameter, and add that to our height map. We run that through a sine function, which just takes our height map values and repeats the function over and over time, so we can get this lovely curve going across our object. And the next few nodes we have here just to refine our wave a little bit more, to make it a little bit more natural and wave-like. The absolute node, make sure all the values in our function are absolute values, so we get more of a band of waves going across the object. Then the values are run through a 1 minus node, which minuses 1 to all the values, and blends and dulls the waves down a little bit. Lastly, we run it through this power node, which takes the value of A and multiplies it to the power of this exposed parameter we've plugged into B, again, just to give more control in the editor. And then one last parameter multiplication for the wave height. Now we are going to add the Y position of the object vertices here to break up the wave a bit, make it look a little bit more natural. And the effect of this is as well, because our first position node is set in world space, and this position node is set in object space. So what we're going to do is we're going to try and combine them. So although we are moving the shader in world space, it's all going to be added onto the object's own space values, so it doesn't go sort of flying away wherever else we want it to. So where were we? Okay, so we're going to take the Y position of this object vertices here to break the wave up a bit, and then combine the whole bunch of positions back again with this combine node, again, so we can get the object space, so we don't have the object flying away. Then we're going to lerp between the original position of the object and our new animated positions. And to lerp something is to go from one set of values to another gradually, and that's what gives us our sort of animated look. And lastly, pop that right there into the PBR master output node for the position. Then we have a shader with animated positions. So in summary, we created our height map from the positions of the objects, animated them, refined the shape, and then applied the height map back into the vertex position of the object. Now we're going to go into the albedo of the shader, so the color. Now, as we mentioned before, the albedo is split into two main sections. Firstly, we have the base color. All we do for that, we grab the height map information that we created earlier and take that, pop that into a contrast node. Now this node gives us control over how contrast we want the two colors to be. So these ones up here. Then we get that plugged into a lerp function, and the two parameters there which are exposed are the color parameters, which we've put a light color and a dark color in. That's two colors we can now lerp between. So the reason these color nodes look a little bit different is because if you right click and type in color, if that's load, so this is the same as that one, but this one hasn't been exposed to the editor, converted into a property. So if we want that to look the same as that, we're just going to right click and convert to the property. And again, this just allows us to expose it to the editor so we can use it and customize it while actually in the Unity editor. So that's the base color done. And we're going to go down into this function here. It looks quite complicated, but we'll try and break it down. We will start at the top here, where we take our time function, and we're going to multiply the UV offset of the object by that. So over time, the UV offsets are constantly changing and therefore making animated. And as you can see, when we plug that offset animation into a simple gradient noise node here, we get a nice ripple going across. And we're just going to multiply that down here by half so we can dull it down a little bit. Now let's circle back on ourselves a little bit here. We are going to have another position node where we grab the position values of the object in the world, combine the X and Y values, and then pop those into our UV ports so the node knows, so the shader knows where the UVs should be on the object in the first place. On the bottom here, we have another gradient noise effect, but we aren't animating this one. We have this here so we can add it to the animated noise to get our lovely rippled effect. Now it doesn't look like the ripples we want just here, so what we're going to now do is put it into a step node. And this is essentially dividing the grey, the black, white and grey colours of the height map into just black and white. Just completely absolute black and white. And the step value of the step node gives us control exactly over where the line is between where we want the black and the white. So what grey is going to be white, what grey is going to be black, and what's the cutoff point is between the two. So then what we have to do is we just have to pop this through into the multiplication node. That gives us control over how visible the froth is on top of the lava. And once we've done that, as before, we just lerp between the two color values here, add that to the base layer, just by multiplying it through this node and plug it all straight back in to the PBR master. And there you have it, animated albedo and animated position. Well, thank you very much for listening to this tutorial, and hope you have fun. Bye.